Good morning, good afternoon, everyone. Thank you very much for joining us again for another session of our Climate and AI Innovators Speaker Series. This is a speaker series organized by CFAL York in collaboration with Innovation, Science, and Economic Development Canada. We are very happy to have you in this session as we start this in a couple of minutes. I should mention that this is a joint work also with UNITAR, that is United Nations Institute for Training and Research. The idea behind this speaker series is to provide a space for innovators in this very important area of work, as we see every day the impacts of climate change on different levels of society, from ordinary lives to infrastructure to many forms of crisis that we are facing almost daily in different parts of the world are rising. And so one of the areas that can meet this challenge is innovation, and to support and build capacity in this area, we have come together to inform more about what's going on in this area and what innovators are doing, what are their solutions, and especially because of the emerging AI solutions and integration of AI with existing or other solutions, it's important to have this area right in front of us and discuss it further. And we are very happy that Dr. Human Razavi is running this speaker series. Thank you, Dr. Razavi, for organizing and running each session. It has been quite interesting. This is our fourth session. And we continue this, and we will be reaching out to more innovators in this area. And so if you know particular companies, ideas, researchers who are working on this area and would like to participate as presenters, we welcome them. Just reach out to us, and we would be happy to provide the space to you for future sessions. In this session, we will have Luke Corbeth from the head of R&D sales at InDro Robotics. He will be provided. We will provide details about them momentarily. Dr. Razvi will be providing that. With that, I'm going to pass it to Dr. Razavi for introduction and introducing the speaker, and looking forward to an interesting conversations, as this is a little bit different from our typical speaker series that we have. It is more open to conversations and also open to the questions that you may have. So please don't hesitate to type in your questions as we move forward, and looking forward to conversation. Thank you again, Luke, for accepting our invitation, and thank you, Human, for running this session. Back to you.
Hello, everyone. Thank you, Dr. Askari, and welcome to the ClimateTech Innovation Talk series. My name is Human Razavi, and I am the moderator of this talk series. For those joining us live, thank you for being here. And to those who will be listening to this conversation later, we are glad you are part of this community as well. At ClimateTech Innovation Hub, we focus on exploring how artificial intelligence can accelerate climate solutions, improve resilience, and support the transition to a sustainable future. Through this series, we highlight founders, innovators, and leaders who are building real-world climate technologies and scaling them for impact. As emerging technologies and hardware innovation become increasingly important in addressing global challenges, empowering critical infrastructure, and supporting more sustainable and resilient industries. We are excited to welcome Luke Corbeth, Head of R&D Sales at InDro Robotics. In this session, Luke will share insights into the role of advanced robotic drones and autonomous systems in driving innovation across sectors, with a particular focus on climate tech, maybe environmental monitoring, public safety, and industrial applications. Drawing on his experience at one of the Canada's leading robotic companies, he will discuss how hardware innovation is accelerating technological transformation and creating new opportunities to tackle complex challenges such as wildfire management, infrastructure resilience, and emerging defense needs. Hi, Luke. How are you today?
I'm doing really well. Thank you so much for having me. Looking forward to it.
Thank you so much. We are excited to listen to your talk and to see your slides. Thank you.
I can there we go. Would you like me to lead with a bit of a introduction, just to kind of who I am and who we are?
Yeah, for sure.
Okay. So, as mentioned, my name is Luke Corbeth. I'm the head of R&D sales here at InDro Robotics. For those who don't know InDro Robotics, I'll give a little bit of history, and then I'll explain kind of what my role is and why I think I'm qualified to talk about this. We started back in 2014. We were actually foundational in establishing a lot of the drone regulatory environment that exists in Canada. We basically work directly with Transport Canada, and as a result, we have a lot of firsts under our belt. So we were the first to fly beyond visual line of sight, first to fly over cellular, first to get our CTA license to do registered drone delivery, and quite a few others. But over time, obviously, we realized that drones are hard. They are limited by battery and regulation and other things. So we expanded into not just capturing data from the air, but also capturing it from the ground, leveraging systems like unmanned ground vehicles, quadrupeds, humanoids, and more. At first, we provided them, largely in a R&D open source capacity, but over time, built out expertise in integration and software development to ensure that we can meet a variety of different kind of client needs, and then eventually evolved to the point where we have robots deployed today doing everything from critical infrastructure inspection to security to inventory counting to delivery and everything in between. My role here at InDro Robotics is I'm fortunate enough to kind of have a front row seat to see, what is the most cutting edge research that universities are working on, some of the largest companies in the world, what are the problems they're trying to solve with these types of systems. And we take a very kind of modular approach to building out the hardware and the software to enable that type of work. Human, are you gonna ask the questions, or would you like me to kind of list the questions and go through the slides?
No, please continue the slides, and after your presentation, I will ask some questions.
Oh, the slides I've kind of created here are largely designed to just kind of support the discussion of the questions.
Okay.
Would it be okay to jump right into that?
Yeah, please. Yeah. Yeah, I can start with some questions, and you can support your response with your slides. And the first question is that, as you know, climate change requires innovative solution for monitoring, adaptation, and resilience. And could you please explain how do you see drones and robotic contributing to addressing these challenges, and talk about this for our audiences? Yeah.
Yeah, absolutely. So their robots come in all different shapes and sizes. You can see quite a few here. Ultimately, we see it. I'll talk about ground robots first, and then drones. Having a system that's adaptable, not just one thing off the shelf, and then kind of being able to tailor it to specific use cases and problems is critical. To do this, sometimes the environment you're operating in, if it's something like an agriculture field, requires more of like a tracked platform. If we're doing obviously something in the sky and we need kind of a large view of how things are developing or the current status of agriculture or forest fires, things of this nature, we we need to be able to kind of combine together the powers of UAVs, UGVs, and ground-based systems to collect kind of the required data to make informed decisions. Um, this can take form in a number of ways, right? Like we can be looking at nature more holistically. We can be looking directly at the infrastructure that supports and guides our power generation, power delivery. Um, Lots of different ways you can kind of adapt these sort of systems for a wide variety of use cases.
Oh, great. And could you please share some examples that how your company and your technologies be applied in related areas? Some, if you can provide some real world examples, it
Yeah,
could be
absolutely. Yeah,
appreciated.
so things like environmental monitoring. So for example, flying fields, flying large forests, looking for potential causes for wildfires. That's been one that's been highly relevant as we all inhaled a little bit of smoke this summer, unfortunately. Um, that's something that can leverage, both drones and AI. So in that example, we can add onboard compute to our systems, leverage machine vision models, and essentially assess situations completely in real time. This can be done both reactionary and preventatively. So on the preventative side, it's, hey, let's look for extremely dry spots. We can use something like a multispectral camera to help identify those types of scenarios. We can highlight those on the edge, and then we can also download that data and leverage a little more compute power than what's available on the hardware itself to explore these things kind of retroactively. So, that could be an example of environmental monitoring. In the case of drones and disaster response, you can see this drone on the screen here actually has a payload for goods delivery. We've done everything from, delivering pharmaceuticals to like remote native communities off the coast of BC. Um, when people are kind of distressed and in hard to reach places, getting them these sort of critical supplies is something we're uniquely capable of doing. And then the way you do that needs to be facilitated through, some kind of infrastructure as well. So in a lot of these cases, you are flying beyond visual line of sight. So you either need a super long range radio type communication system to the drone, or you can leverage something like 5G for real time and command and control and have a, really talented pilot, whether they're nearby or across the country or in a different country, commanding that drone with a lot of confidence in what is typically a high stakes scenario. So those are some examples with drones. I think I can get into some more of the robot ones here in a second.
Yeah, and great experiences and many. As I know, yeah, you are a kind of SME and a small size startup, but many climate challenges occur in remote and hazardous environment. How you support the teams, the researchers or other company operational teams in the Canada wide. Could you please explain and discuss about your operational challenges?
Yeah, absolutely. I can talk to a few different applications here. So I did mention, critical infrastructure, energy and power delivery. And so this robot you're seeing here is an example of Sentinel, which is our like critical infrastructure inspection robot. And so if you take like the utilities industry, for example, obviously, the power lines you see along the road, those are converting power from some kind of power generation plant, bringing it to the substation, and the substation transforms that energy into power that's usable in our homes. And so that is critical infrastructure. Anytime there is a blackout, it's typically the result of some type of substation malfunction. And so either you can take the reactive approach and, hey, it's broken, we've got to go fix it, or you can take a preventative maintenance approach. And so that's what autonomous ground vehicles are exceptionally good at. which is, hey, every day let's look at key aspects of this site. Let's look at gauge and dial values. Let's look at temperature readings on transformers. One of the leading causes for power outages is actually nesting animals. They like the heat. So looking at the top of poles for nesting animals. There's also a security element there, like looking at fence lines for break-ins and all of the and then corrosion or rust on the equipment. All of this can lead to a potential failure. So by deploying a autonomous system to capture this data every day, you can see as things are, trending in the wrong direction, and then send in the appropriate personnel to solve that problem before it becomes a larger issue that results in downtime. Um, there are obviously, natural disasters, for instance, that are unavoidable. But even in those situations, a system like this allows operators to remotely teleoperate into the robot, assess the site, assess the damage, understand the type of resources that need to be deployed to get that type of infrastructure back online before as quickly as possible. This utilities example is a compelling one, and it's one that we've deployed quite a bit, both in Canada and the US. But this idea of autonomous kind of critical infrastructure inspection extends beyond just utilities. So in oil and gas, that might be well pad inspection. If things go wrong there, there are some, critical critical environmental outcomes that are not great. So making sure everything is up to regulation and working as intended is super important. This can also extend to nuclear. It can extend to solar. We're actually going down to Germany next month with a robot similar to this one to inspect solar panels. That's also a really interesting use case. You'd think, maybe drones are best for that, and they are very useful. But it's actually the vegetation encroachment on the connectors and the cables that unplugs the solar panels. So you care more about assessing kind of the underside of the panel to identify the core issue. So that's just another one. The nuclear one is interesting as well. Obviously, nuclear, there is some debate on how effective it is, but being able to kind of assess the infrastructure in that industry is quite important too, and it does present a lot of challenges to the people who are responsible for that. So we do have instances of humanoid robots being controlled through VR teleoperation. So instead of sending in a person in a hazmat suit into a contaminated or radioactive area, let's just have the robot live there kind of indefinitely. That same professional operator physically embodies the system and would carry out the tasks that they typically would, just without putting themselves at risk. So this idea of robotics autonomously doing preventative maintenance or taking people out of harm's way is super impactful.
Oh, great. And as you mentioned, Canada is currently facing two major challenges, increasing wildfire and natural disasters like these, and growing defense and security needs. How do you see drone and robotic technologies help addressing these challenges? And how is our situation right now? Is it at the time we are working well with them or not?
Yeah, so I'll talk about wildfires first and then defense second. As it relates to wildfires, the unfortunate reality is, once a wildfire kind of breaks out, it's very challenging to stop that. So, you're probably seeing a bit of a theme here, but using robotics as a source of preventative maintenance is typically the best way to mitigate or at least minimize the impacts of wildfires. And so, keeping constant eye of high risk zones is critically important. Flying drones to do that is the best way to get those vantage points and cover really long and large areas in a quick amount of time. Um, Typically for applications like that, you'd want to leverage some kind of fixed wing drone system rather than like a quad rotor type drone that's very popular because those systems have, longer flight times, can cover more area in a single flight on a single battery. And then doing something with that data once it's collected. Like I mentioned, our systems are typically outfitted with jets and computers on board, so we can do a bit of the analysis on board in real time, and communicate that data back to the operator, typically over 5G or long range radio. Or that data can be taken and evaluated after the fact, to do a full kind of risk assessment and report. Once the fire actually does break out, though, it is more so a tool to kind of triangulate where it's heading and maybe the best ways to kind of attempt to put it out. That's the wildfire side. On the defense side, um, if our sovereignty were to ever be challenged, it would typically happen in the Arctic. The Arctic is a very challenging environment for ground-based systems, water-based systems, and even drones as well. So how do you combat kind of the extreme cold and ensure that, we would have a tactical advantage in those types of scenarios? Well, you need to explore, different types of power technologies. So, we're looking at things like hydrogen fuel cells to power robots and drones. That tends to work a lot better kind of in the colder climate. Then understanding, what are the temperature thresholds for the variety of sensors that, we need for this equipment to be autonomous. Is it suitable in that environment? If there's icing, how do you deal with that? So there's a whole slew of problems to solve. And I will give credit where credit's due. The government has done a wonderful job trying to fund companies to solve these types of problems. And then there's also the nature of, hey, we've made some significant investments over the decades in some legacy systems. Is there any way for us to change, to turn some of these legacy systems into, more modern robots? And so a lot of our investment in the defense space is geared to do just that. It's like, how do we take an existing ATV or, larger UGV vehicle and just upgrade its capabilities, enable it for teleoperation, enable it for autonomy, and then also explore some net new vehicles, things that leverage, the latest in battery technology or utilize like, diesel fuel generation for longer range, power higher payload vehicles. So there's really a number of problems that we're trying to solve, and they are very challenging problems, hence the amount of funding and investment that's going into that space now.
Yeah, I have some questions regarding investment, but before that, we have a couple of questions from the audiences. Janet asked, how have their technologies been used to help with inspecting erosion? What knowledge input informed their analysis and data gathering?
Inspect which, sorry, I didn't catch that.
Erosion. I think it's related to agriculture field, yeah? Janet, uh, to mitigate extreme rain and flood risk with climate change.
Hmm.
Soil erosion.
Yes, yeah. Um, I have some experience in this, not too much, but I'll talk about what we've done in this space. So in a lot of kind of the ag tech type deployments, soil sampling, for example, is a big thing people are trying to do. Um, to do that, typically you need some kind of actuated soil sampling system. And then you also need to sample across, typically large areas. So we've typically leveraged some kind of autonomous based tracked system, that can operate on kind of the dirt and mud, and then periodically leveraged soil sampling to, capture um, various samples, and then also having like, typically a revolver essentially so that you can capture 12 to 48 soil samples, for example, before autonomously navigating back to kind of analyze those. So a lot of that doesn't really happen in real time on the edge. The robot is more of a means to an end for capturing the samples autonomously. And then that can obviously, speed up that type of evaluation. But that's the full extent to which we've participated in kind of that arena.
Uh, thank you. And Thomas Taylor asked, is there any standard provision or accountability, contractual or waiver-based?
Say it one more time, sorry.
Uh, Thomas asks you, is there any standard provision or accountability, contractual or waiver-based?
Yeah, so the drone industry, very much so. The thing with drones is the biggest risk with drones is what's called a vertical flyaway. So if your last command to the drone is up and you lose connection to the drone and it keeps flying up, it will keep doing so until it runs out of battery and come crashing down. That obviously puts a lot of people at risk, and as a result, there is substantial regulation on drones in Canada, um, in terms of the size of the drone, how you operate the drone, whether it's visual line of sight or beyond visual line of sight, the amount of payload that you can actually have on the drone for it to be safe. So as it relates to drones, absolutely. As it relates to ground robotics, still relatively new. So a lot of the regulatory bodies are exploring robots and how they should be regulated. Most companies tend to take the beg for forgiveness rather than permission approach. We typically do the reverse, which is like, hey, what are all of the things we need to keep in mind before actually deploying? I can get into that in a little more detail. But if it's on private property, a lot of it comes down to just establishing really strong standard operating procedures as the asset kind of owner operator, and determining what makes the most sense within the context of the deployment. You're on mute there. Aman.
Oh, great. I hope Thomas find his response. And regarding the competitors, I want to ask you, as we know, the US and China are leading countries in this area in hardware innovation, but as this field is highly regulated and protected and it's related to national security concerns, how we can assess Canada industry in this field and in the field of robotics and drones for doing the important field of technology. And
Yeah,
could you please explain your competitors across the board, right?
yeah, yeah. Um, I'll talk about the Canada, China, US thing. It Canada actually did have a pretty substantial lead in robotics at one point. Like Canada is known for like the Canada Arm, for instance, on the International Space Station. So, Canada is recognized as a robotics leader. Our domestic manufacturing capability isn't quite on par with China. And our industries don't adopt as much as the US, but we do have a strong place, especially for technologies that do environmental monitoring because we have so much land. And we also have a ton of resources, right? And the infrastructure to pull those resources out of the ground typically require this type of preventative maintenance I mentioned. So I think there is a strong need for robotics, on that front, but also to increase our domestic manufacturing capability. And I don't think we should look at it as one versus the other versus the other versus the other. We should look to these other regions and see what they're doing, whether it's effective, either adopt or adapt those approaches, and come up with new and novel ways to solve some of these compelling problems. On the competitor question, I think we're really unique, right? Like we're very much an R&D company. So people tend to come to us when the solution they're looking for doesn't exist, and we take a modular approach to building those solutions. Um, Obviously, a lot of those are in the same arena. We're just trying to take slightly different approaches. So, example, it's not sustainability related, but with inventory counting, we instead a lot of companies typically only use drones or only use robots. We kind of took our capabilities in both. We power a drone with an AMR platform, and we use that tandem to count the inventory. So, like yes, there are other people kind of competitive in that space, but we try to take kind of a new and novel approach wherever we can. And that sort of innovation is how we try to, stand out, but also, compete on a global level. So all of that's kind of intertwined.
Uh, yeah, and could you please explain how what role of partnership with universities, government, or industry organization play in accelerating role in climate technology development and robotic development?
Yeah, absolutely. So I think the only way for robotics to kind of succeed is through this like interdisciplinary collaboration. It's typically the universities that are really pushing the frontier of possibility and, leveraging funding sources to, you know, get the appropriate equipment, get the appropriate personnel to tackle some really compelling problems. And then from my experience, I typically see it kind of leak over into industry over the following years. So there's, some kind of new and novel discovery, new approach. It gets refined and ultimately commercialized. And then anytime there is this sort of new innovation, there's typically a set of rules that needs to come with it, especially if it is very disruptive, in which case you need collaboration from the government. And so this was definitely seen, in the drone space, as drones became more commonplace, the drone technology was getting improved by universities and companies, then ultimately deployed. And the government said, "Hey, well, there's got to be some rules around how we use this." I think the same will apply to ground robots, especially if you're looking at something like, last mile delivery robots. How do they operate on the street alongside people, alongside cars? So it's definitely a kind of give and take where all of the entities need to collaborate for something to be like commercialized very effectively.
Yeah, and as you mentioned, from entrepreneurship point of view, it seems that creating a company like InDro need a significant investment. Is it true or not?
Yes. So one thing, people will use tech, like the tech industry. That's such a blanket term. I would say any company that does hardware is like running a tech company on hard mode, and I'll explain why. With a software only product like, Salesforce or something like this. If someone wants to try it, there's like basically zero marginal cost associated with giving it to people. The difference is in the hardware industry, there is a marginal cost associated with every opportunity you go after. So you have hard costs on the physical hardware. There's a lot of development time needed. And so a lot of the technologies we've built were spun up and funded through like larger government programs. And the type of work we do wouldn't be possible without that type of funding. But then the important piece after that is to roll that into something that is commercializable. So, it's one thing to get, a humanoid robot to do something cool in a, vertical farming scenario, which is a project we're working on right now. But then taking those learnings, improving on them, automating them, and then getting it into the hands of more than just one company who is like the initial adopter in the program, is critical to scaling, adoption, and further improving those technologies, so you have the money and kind of the burn rate to do so. The other thing, just as it relates to the robotics business, is I see a lot of people build something and then go to market and say, "Hey, is this useful?" Um, given just how difficult it is and capital intensive, like I mentioned, I see most of those companies fail. Um, the appropriate approach would be to work backwards from an existing problem so that you're solving, something that's highly, highly relevant. So we didn't just build a critical infrastructure inspection robot and then go to all those industries and say, here it is. It was more of them saying, these are all the things we needed to carry out. And then you work backwards from the problem. What hardware needs to exist to solve this? What software needs to be developed to ensure there's an appropriate workflow that is better than what they're doing today. So it doesn't make sense to just automate something for the sake of automating it. You have to really understand the problem and then work backwards from there.
Oh, great. And we have a couple of questions from Janet. I think she's working in municipalities. Could you provide more example of working with local municipalities, if any? And the second question is that as municipality, I'm not sure we can afford what large oil and gas companies can do. So could we partner with them and a university to tackle off climate risk related challenges or not? This is a question regarding the collaboration with other clients you have.
Absolutely. So I'll answer the first one first about municipalities. This right here is a picture of our DART sites. We call it the Drone and Advanced Robotic Testing and Training sites. We've got a number of kind of standardized tests we can put our robots through to understand, what they're capable of in different scenarios. You'll also notice kind of on the right here, we do have like standard curbs as well. So, an example was one of our partners was deploying like last mile delivery robots, and the municipality wanted to understand how it deals with things like curbs and different terrain types, and try to build some regulation around that. So hey, let's come to a safe space to do that sort of testing and validation. Let's build the appropriate rule set around that, and then let's deploy. There's a infamous example of a company called Tiny Mile who did the exact opposite, and they took that beg for forgiveness approach, just deployed in a variety of different cities without asking the municipality, and then subsequently got kicked out of those municipalities. And so they've moved around 5 or 6 times. Not the right way to do it. So doing this kind of safe testing and validation before deploying, I think, is critically important. So that's the municipality question. For the next one, you're absolutely right. For the reasons I mentioned that, hey, robotics is really hard and capital intensive. Oftentimes, this like multi-stakeholder collaboration is the only way to bring about this type of true innovation. And it's also good validation that you're solving a compelling problem if you're working with the end adopter throughout kind of the research and development phase. So if there is an oil and gas company, for example, that has a compelling problem and comes to researchers or companies and they collaborate to build something, then for sure you're working on something that will immediately provide value. And hey, if this company is going through this problem, there's probably a bunch of other ones with a very similar set of problems. So then that's like a really strong and true path towards commercialization, rather than, let's build something, then, try to go to them after. Because they can also have a say in, what is and isn't valuable, right? You can tell based off everything we do, we're experts in unmanned systems. We can't be experts in oil and gas and utilities and nuclear and solar. So relying on like the insights of those industry professionals goes a long way. And hey, if they're willing to fund and back up a project, then those are the type of ones you really want to be on the lookout for.
Very good, thank you. I have a couple of questions for wrapping up my question list. But before that, I want to ask Professor Askari, as Dr. Askari and his colleagues at York University and CIFOL are highly active in this field, and they have several labs working with drones. Maybe he has some questions regarding your products or your journey. If you
Sure.
have, yeah.
Sure. Thank you very much. Thank you. This is exciting. Thank you for sharing your work with the participants. And one question that came up to my mind right in the first part of the conversation is on your drone delivery with drone, especially emergency delivery.
Yep.
I noticed you had a payload attached to your drone. My question was about if this payload is your product or you use off-the-shelf product to use for this kind of delivery.
Yeah, it's a great question. We've tried a number of different approaches over the years. So this one here that you're seeing is very simple, right? It's just, hey, we've got a really big landing gear. So, let's create some kind of vessel for whatever we're delivering. In this case, it was pharmaceuticals. And then let's just have the drone land, someone approach the drone and grab it. And so in that type of use case, we didn't need to over-engineer the problem, and it very simple solution. We've done other things like AED delivery. So if someone's having a heart attack in the forest, I believe the stat is every minute that goes by without them getting the defibrillator, their chance of death increases by about 10%. So time is really of the essence there. We don't have time to necessarily land the drone and have someone grab it. Um, in that situation as well, there might not even be a landing zone that's suitable for the drone. So for that application, we leveraged a winch type system that we did develop in-house. And so the winch comes down, the package hits the ground, that pressure makes the claw kind of disengage, and then whoever's on the ground can immediately run up, grab it, and utilize it. So um, it's very application dependent. It also brings up a broader question of like build it versus buy it.
Yes.
Um, because we are tackling so many applications, like if there is something that exists in the world that solves the problem already, we don't necessarily need to build that exact same thing from scratch. We'll find a way to integrate it into the complete system and solution. So it's super effective. And so that usually results in lower cost and lower time to market. So it serves as a better way to kind of validate different ideas and use cases and workflows.
Right. Thank you. Have you had cases where you work or use those that, especially in emergency kit, for example, sort of, or any emergency or first aid kind of supply that you have to drop it instead of landing it or getting too close, where
Hmm.
sometimes it's just difficult to reach out very close to such that someone grabs the supply, and we have to basically drop it.
Yep.
And have you had cases like this and any tests on how the equipment and or the supply are reached safely or you?
Yeah, we collaborated with I believe it's a Canadian company called AVSS, and they do laser guided parachute
Hmm.
parcels. So, we had provided a system that allowed them to integrate their payload delivery, and leveraged it. They leveraged it very effectively. And you're right, in some situations, that is kind of the optimal delivery mechanism. So I would say, yeah, that's kind of the third big, delivery approach. One would be like you're seeing on the screen here, kind of basic landing, stop, pick. Second would be winch. Third would be, parachute guided delivery.
Right, right. Thank you. That's great. That's
Yeah, my
all my
pleasure.
question for now. Back to you, man.
Yeah, thank you, Doctor. And as my last questions, looking ahead, Luke, how do you see emerging technologies such as AI, advanced sensors, hardwares and autonomous navigation shaping the future of climate robotics sector?
Yeah, everything keeps getting better. If you've noticed, a lot of what we've done doesn't require physical interaction. So it's more on kind of the inspection side, like looking at things, not like physically engaging. I think that's kind of the next big frontier, especially as these like vision language action models get better and better, being able to kind of perform tasks. Where you are using arms or grabbing things. And this is very challenging to do today at scale, but through a lot of the work coming out of universities, coming out of companies like NVIDIA, for example, with Isaac Sim, a lot of that is getting easier and easier. I'm hoping robotics kind of gets its big AI moment in the coming years. The two are kind of in bundled together, but they are very, very different. Anytime you see a headline about AI, usually you see a robot, but robots haven't had that same kind of moment, like same kind of chat GPT moment, if you will, where you can just verbally command it and it does some sort of task. That's a pretty big misconception. Um, a fun little anecdote. I had someone the other day ask me if they could buy a humanoid to drive their forklift. I can't do that in good conscience. The technology isn't capable of that yet. But over time, it just might. Um, that's not a particularly strong use case, but there are some very strong ones that technology is going to be better at. And then also the hardware is improving as well. So the capability of things like dexterous hands, um, the runtimes of these systems, the payloads of these systems, they're all just getting better and better. There might be a world where a humanoid robot can walk through a field and do soil sampling. Um, we're not there yet, but if we're looking ahead, like that's certainly plausible. What makes humanoids specifically very exciting is that the world is built for humans, and so we don't need to change the infrastructure around the robot. The robot adapts to the existing infrastructure. So basically, putting systems into places that are built for us and having them do tasks effectively is kind of a next big step. I also think, AI is getting better so we can do more with the data we're collecting. So better forecasting, better predictive models. So taking what these systems are capturing and using them as just a means of collecting more data so we get better and better outputs from the models that we're creating. So those are some things that excite me and where I kind of see it going.
Great. And as last question for students, young entrepreneurs, researchers, and who are interested in building climate hardware solutions and building some companies like this, what advice would you share about developing impactful technologies and bringing them into market?
Hmm. Um, I'll talk about skills first because robotics is, I would say, very interdisciplinary, right? Like there's so many, for a full solution to exist, there's so many different skill sets you need, both from the hardware side and the software side. So building a really strong team is super important, like covering kind of all those bases, for the solution you're ultimately building. Um, Two would be seeking government funding. The government of Canada does a lot to promote this type of innovation, and those programs do exist, and they give you the runway you need to tackle these problems seriously with strong teams. Um, Three would probably be don't reinvent the wheel if you don't have to. So it's very tempting to start from first principles and build everything from scratch. The reality is just given how complex these systems can be, leverage what's already available to you and build on top of it rather than starting from scratch where possible. I see companies kind of be more successful if they adopt kind of that mindset. Fourth would probably be what I'll call back to what I said earlier, which is, start with the problem and work backwards from the problem. A lot of people build solutions for problems that don't exist and think they do. Where if you can get that kind of market validation and feedback and know that, what you're building towards will actually have a really strong impact in the industry or for the environment, that is really powerful, but it's also kind of like invigorating and inspiring for the team that you have a common goal you're working towards. Um, yeah, I think those are some good ones. Yeah.
Thank you. Thank you very much. Look, is there anything to add? My questions
Um,
are over.
No, 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 no. I think hopefully I provided a bit of value. Obviously, I have a lens for this from kind of the commercial perspective and how I've seen companies adopt it and researchers use this technology. If anyone has any questions, feel free to reach out to me. I'd be more than happy to answer them.
I
Thank you.
received one question from Thomas. If I'm not sure if you have seen that before.
Yeah, please. Yes, we have another question from Thomas. Have you run, the question is
Yeah.
this, have you run into an issue where a machine missed a critical problem it was designed to detect, and what would a customer, public or private, do as resource? Is the machine subject or liability?
Mm-hmm. Yeah, so what the robots today are really good at doing super reliably is being like autonomous or teleoperated data capture tools. But then once you have that data, there's a variety of different ways you can kind of engage with it. One would just be manual review. Um, the second would be, building some kind of machine vision model to kind of detect that anomaly and m- take the appropriate action as a result. Um, in all cases, though, it's best to check your work. It's a little challenging to just always assume that the robot is always right, especially early on. You kind of need to build out a strong data set before it becomes extremely reliable. So, working hand in hand with the end user to ensure that, hey, yes, like everything you do want to capture is actually captured by the model. And anything you want included in a report is actually included in the report. That's just about having like really good rapport and communication with the end user and the client.
Yes, thank you. Thank you, Luke. The time is near to over. Thank you, Luke, for your engaging and insightful presentation. We greatly appreciate you sharing your experience and perspective on hardware innovation and climate transformation via
My
robotics.
pleasure.
We wish you continued success and growth in your future and look forward to following the exciting work of InDro Robotics and your team. Thank you, everyone in the audience, for joining us and for your continued support. We look forward to seeing you again in the last week of August for our next session, where we'll welcome another inspiring speaker and explore new ideas shaping the future of innovation and technology. Thank you, Dr. Askeri.
Right. Thank you very much again, both of you, for presenting and also the very interesting conversations. And thank you all participants for joining again this meeting and session. I really enjoyed the work you are doing at York University in Advanced Disaster Emergency and Rapid Response Simulation Lab and CFOL York. We have a drone school. Part of it is research work, some of which are quite very well aligned with what you are doing. And certainly from our side, we would be happy to explore possibilities for collaboration and research, especially in areas that you are working on, if needed. And with that, we are closing this session and looking forward to see you all again on end of August for our next session. That is going to be another interesting conversations continuing in this area. Thanks a lot and have a very good day and best of luck for with you, Luke, and your team.
Thank you so much. Appreciate it.
Bye-bye.
Bye.